So maybe you've seen one of these awesome YouTube videos where someone takes a big chunk of sodium metal and they throw it in like a bathtub filled with water. There is a gigantic explosion and flames and smoke. Or maybe you've just seen your chemistry teacher cut a little piece of sodium metal and throw it in like a bowl of water. The sodium skitters along the surface of the water, throwing off sparks and fire. If you haven't seen either of these demonstrations, you might want to pause this video and search YouTube for something like sodium metal water explode. The results you get will be awesome, but trust me, don't try this at home. Now, look, even if you haven't seen any of those demonstrations, take my word for it. Sodium metal reacts explosively when you put it in water. It's crazy. Now, when people watch videos showing the demonstrations that I talked about, a really common question that they have is this. They say, well, sodium metal reacts crazy explosively when you put it in water. But what about table salt? Table salt is made of sodium chloride. So there's sodium in table salt too. Why doesn't table salt react amazingly explosively when we put it into water? That is such a good question. It's such a great question. And here's the answer. The answer is that sodium metal and sodium chloride both have sodium in them, but they have different types of sodium atoms. The sodium atoms that make up sodium metal are highly reactive. They're agitated and unstable, super energetic. Whereas the sodium atoms that are part of sodium chloride are much calmer and much more relaxed. Now, here's how these two types of sodium atoms are different. The type of sodium atoms that make up sodium metal, the agitated ones, are neutral sodium atoms. They don't have an electric charge, they're neutral. They have 11 protons and 11 electrons. The protons and electrons balance each other out, giving sodium here a zero charge. It's neutral. On the other hand, the calm sodium atoms in sodium chloride are ions. They are sodium with a 1+ charge. These sodium ions have 11 protons and 10 electrons. And this makes sense because in sodium chloride we have the Na+ and it's paired here with a Cl-, forming an ionic bond. So the big difference here is that the explosive sodium atoms have a neutral charge. Those are the kind in sodium metal, whereas the relaxed sodium ions in sodium chloride don't react explosively. So that answers a question. But I have another one. Why is it that one electron makes all the difference between explosion and a tasty flavoring? Why is it that this neutral sodium atom, it reacts so explosively, but you take one electron away and this one doesn't react explosively at all? Let's talk about that. So the big difference between these two types of sodium has to do with how the electrons are arranged in the different atoms. Here's a diagram that shows the electrons in neutral atoms of sodium found in sodium metal. In the center here is the nucleus of the atom that has 11 protons. Then these dots represent electrons that are arranged around the nucleus in these circular energy levels. Now take a look at this. In the outermost energy level there is one and only one electron. It is this one electron that's the reason why sodium metal and the atoms in it are so agitated, so unstable, and why they react violently when you put them in water. Here's a reason why. Sodium metal wants to get rid of this one electron so badly. It is so frustrated by the fact that it has this one electron because this one electron is preventing it from having a full outer or valence energy level. Right? If it could just get rid of this electron, it would have this as its outer energy level, which would be full, and this would make a very happy, stable atom. So, all it wants to do is take this electron, spit it out, get rid of it, and turn into this atom here. Now this is the sodium 1+ ion. Check it out. It's identical to the neutral sodium atom, except it has lost one of its electrons. The electron that used to be here has disappeared here. It has gone off. And so this is the sodium 1 plus ion that is much calmer and much less agitated. So, sodium metal really wants to get rid of this electron. How does it do it? Well, this is where water comes in. Sodium wants to get rid of this electron, but it can't just like throw it away in the trash. It has to give it to something else. And it's able to give it to water. Water is willing to accept it. So, when you put a hunk of sodium metal into water, the sodium atoms in it are like, oh, finally, we've had this electron for so long and we can finally get rid of these electrons because water is willing to take them. So, when sodium metal releases this outer electron to water, that creates, or I should say it releases, a tremendous amount of energy. So, here is a quick chemical equation that shows everything that's going on here. We take neutral atoms of sodium that are found in sodium metal, sodium with a 0 charge, a neutral charge, and put that into water. Now, this causes the sodium metal to release and give up this outer electron, give it to water, and that turns the neutral sodium into sodium ions with a 1 plus charge. These right here. Now that's not the only thing that happens. The other thing that happens is hydrogen gas gets released. Hydrogen gas is super explosive, it is super flammable, and it is quickly lit on fire by all of the heat energy that's being released when this electron gets given to water, because this is a highly energetic process where lots of heat energy is released and it sets the H2, the hydrogen gas, on fire. This is what causes the flames and the popping and the explosion. So, that was the long story. Here's a short story. Sodium metal reacts violently when you put it in water because the atoms inside of it have this one outer electron that all they want to do is get rid of. Sodium chloride, on the other hand, is made of these sodium 1 plus ions that have already lost this outer electron, so they're super calm, they're not agitated, they're super stable, and instead of reacting violently with water, sodium 1 plus ions just kind of float around and hang out in water. They make a delicious seasoning.